All right, some more math videos. So this is from section 2. Seems like most of you guys got the reverse engineering part down. At least when there's 3 terms. This is a little weird. Things are out of order. There's not 3 different terms. So what do? Well, the same thing we always do. We try to make it easier to look at, use what we know to figure out what we don't know. And there's 2 real ways to solve this. I'm going to show you one way, which is kind of like just do this to make it as obvious as possible. And the other way, we're just going to turn on our brains. If I rearrange this by adding y squared to both sides and subtracting 200 from both sides, using the properties of equality to rewrite the equation in a better way, that becomes 0, this becomes 0, and of course what we end up with is 0 equals 0 plus y squared is y squared minus 200 is this. So here's our new question. And so we want to factor this to make it easier to work with, I suppose, is what a lot of people are trying to do to figure this out. But because it doesn't have that middle term, it's kind of hard to figure out what's going on here. As hinted in a previous video, if there's no middle term, it means we have conjugates. So you can think of this as y and y to get y squared, right? Y times y gets you that y squared. And then we need the same thing, but different signs here. So that when we get that many y's and that many y's, it goes away. We don't get any regular y's, no linear term. And then they multiply to negative 200. So I need a number times itself to get me 200 essentially, right? Because I'll get the negative for free now that I've set it up like this. So what times itself gets you 200? In other words, what's the square root of 200? Well, if you know your squares, you probably know that 12 squared gets you 144. So if I needed 144, I'd need 12 and 12, right? But this isn't 144, it's 200. What about 13? Well, 13, if you didn't know, now you do, is 169. So if this is 169, you'd use 13 and 13. Maybe it's 14. Well, it's not, because 14 is actually 196. And you can tell that it'll end in a 9 here because 3 times 3 is 9. You can tell this end in a 4 because 2 times 2 is 4. You can tell this end in a 6 because 4 times 4 is 16. So that doesn't work. And of course, 15 is too big, and it will also end in a 5. It's actually 225. So it's got to be somewhere between 14 and 15. It's not a nice number. And when there isn't a nice multiplicative half, as we call this, right? The multiplicative half of 144 is 12, because half of it multiplicatively is 12, right? The thing that multiplies by itself twice to get it is 12. We use roots. So the number you need here is actually the root of 200, which is 14 and change. And we also need the same thing here, but different signs. So negative root of 200. And this will reveal our answers. Y can either be negative root 200, because if I plug it in here, I get 0. And here I get 2 negative 200 roots 200. But who cares? 0 times anything is 0. Of course, the other answer is when this is positive, right? Because if I plug that in here, this becomes 0. This becomes who cares, because 0 times anything is 0. So there are your 2 answers. Now, you could have figured this out without doing any of that, but I do think it's beneficial to see it. Right, understanding no middle term means we have conjugates. What numbers do I need here? I can even show you for sure that this is the same equation as what we have here. Y times y gets you y squared. Then we get, and I'll write this down, the negative root of 200 times y. And here we get the positive root of 200 times y. Of course, anything minus itself is 0, so it's gone. And then here we get negative root of 40000, and that does come out to the root of this is, of course, 200. So that gets us this. But anyway, you could avoid all of that if you just look at this problem as is. Okay, so I'm going to rewrite it what it was before. You could also look at it like this. But if you think about it, we need this to be 200, don't we? So that when we subtract it from this, we get 0. 200 minus 200 gets you 0. So what number times itself gets you 200? It's the same question we were asking over here. Well, the answer, of course, is either of these. Either the positive version or the negative version. Boom, done. This does not simplify because we know it's a number between 14 and 15. If you wanted to, you could simplify this by factoring the 200. So let's talk about that. Hopefully this is a little bit of a review from geometry. But you can factor this as 2 times 100. I could also done 20 and 10, or 4 and 50, or any other thing. But my goal is to find numbers here that I can root. And I know the root of 100. The root of 100 is just, well, it's 10, right? So another way to write this is y equals, let's get the plus or minus in there, plus or minus 10 root 2. So we rooted as much as we could out of it. We can't root 2 because 2 doesn't break down, right? Number times itself gets you 2 is 1 and change, so we're just going to leave that alone. So that's another possible answer. Break it down by factoring and try to root as much as you can. Cool. So that one's weird, and I feel bad for that being the first question they ask. Or one of the first questions they ask, because it kind of throws you off. You think you understand stuff, and then you see that, and you're like, wait a minute. And it's nothing. It's just the same thing, just slightly different. Here's where a lot of people get thrown off too. First off, it's because this isn't in the right order. So let's just change the order. Let's put our quadratic term first, our linear term second, and then 243, our constant, third. And the reason I didn't have to do properties of equality to move them around like I did to move these around is because notice I'm not switching sides here, right? Here's our equal sign. So I'm not trying to move these over to the right. I'm keeping them where they are. I'm just switching the order. So as long as I don't change the signs, you can put them any order you want. They're all positive, so we're good. And the thing that throws people off here is they try to factor it as like 3x and x, which does get you 3x squared. But now they have to consider what number do I want over here getting times by 3 before it adds up to 54. And that's not impossible, but for this one, you actually don't have to think that hard. So this is an equation. And just like earlier, we can use properties of equality to move things around or simplify. If this wasn't an equal sign here, you could not do this. But because it's an equation, I can divide everything by anything I want, and I'm actually going to divide everything by 3. Every single term. When I do this, this of course becomes 1x squared, so just x squared. That's why I did it. 54 is also divisible by 3, and I know that because 3 goes into 60 20 times. And this is 6 away from 60, so it's 2 6s away from that, or 2 3s away from that. So instead of 20, I'm going to get 18. And you can check that. 3 times 10 is 30. 3 times 8 is 24. Yep, that gets you 54. Over here, 0 divided by 0 is 0. So let's just get that out of the way. 243. I know that's divisible by 3. I'm going to show you how. It's kind of the same way I did this last one, but I'm going to write it down. I know 3 goes into 210, and there's 33 left over. So if 3 divides both of them, it divides 243. It divides 210 to 70, and it divides 33 to 11. So it looks like 81. I shouldn't write that down here. Here we go. 81 is how many times 3 goes in there. And you can always break numbers down like that. Break it down into one you know does work and see if the leftover does. So it looks like 3 times 81 is 243. That makes sense in my head because 3 times 1 ends in a 3. And then 3 times 80 is 240. So here we are. And this is a much easier problem to solve. And it will have the same answers as this one because we didn't change the problem. We just made it look different. So I need numbers that multiply to 81 and add to 18. Well, it's going to be 9 and 9. So our answer is x equals negative 9 with a multiplicity of 2. So it counts twice. There we go. Let me move that up. Cool. So there we are. So the big thing here was knowing that since it's an equation, you can use properties of equality, and everything's divisible by 3. It'll make your life a lot easier. All right, so that was part E. We're going to take a look at part F. This might even be easier than the last one, but it's the same idea. You need to know that you can use properties of equality to make this easier to work with. And I think the best thing to do is just times everything by 2. Because timesing everything by 2 will make this -9, and it'll make this +7. You could also times by 10 to move the decimal place over, but you would have noticed that you could then divide everything by 5. So 2 is the easiest number to work with here, and it makes everything a whole number. So we get this. And while it kind of sucks that we have a 2 in front of here, the only way to make 2t squared is 2t times t. And of course, there's only one way to make 7. It's 7 and 1. And we need it to be positive, so either I'm using 2 positive signs here or 2 negative signs. I'm going to use 2 negative signs. That way I can get a negative answer for my linear term, its coefficient. So I want to use 7 and 1, and the question is, do I want to put the 7 or the 1 here? Because whatever I put here is going to get doubled, and then it's going to add with the other to make 9. And I don't want to put the 7 there because that gets me 14. But I'll put the 1 there to get me 2. So now I have -2t's and -7t's makes -9t's. This is the same thing as that. And so now I can answer the question of when this thing equals 0. I'll get 2 answers. T equals 1 will make this equal 0 and this equals something else, but 0 times anything is 0, so that works. And then for this one, I need 7/2. And the reason 7/2 is the answer is because if you think about it, I need this to be a 7. So I get 7 minus 7 is 0. But of course, if I just plug in 7, I don't get 7, I get 14 because there's a 2 there. So what do I double to get 7? Well, this number. Do you see how if I double this number, the 2's divide out and I get 7? So those are our 2 answers. And they will work in the original because, of course, this is the original. It's just a different way of looking at it. We're just changing perspective. So yeah, timesing by 2 or timesing by 10 to move decimal places over and then simplifying as much as possible. Then factor. Not too bad. So that's part F. We're going to look at 10-2-2 and 10-2-4. But before we get to 10-2-4, we need to look at 10-2-2. So this says, find the sum and the products of the roots. Because these videos aren't teaching videos, they're more like review or just here's a little bit of a help along your way. I'm not going to go fully into this. At least I'm going to try not to. But the sum and product of your roots means this. So whatever the numbers are that make this whole thing equal 0, those are your roots, right? We just found some in the last problem. It was 7/2, right? And then we had another one. I can't remember what it was. But those are going to be your answers, right? Your roots that make this equal 0. And we want to know what happens if you add those together and multiply those together. Well, as we learned in class, the sum of the roots will always be equal to -b over a. When you add up your answers, they'll always give you this. And when you multiply your answers, they'll always give you this pattern, c over a. And I want to make clear what those are. So when you have a quadratic, you'll have an x squared, and it'll have some number in front of it. In this case, that number is 1, because it's just 1x squared. Then you'll get some number in front of your linear term. Could even be 0. In this case, it's 15. We call that the b value, or the coefficient of the linear term. And then you'll have some number added on that's your constant, or the c value. And of course, in this case, it's subtracted, so c is negative. And our sum will always be equal to this. So if we look, we want the opposite of whatever b is. Well, if b is positive 15, what I need is negative 15. And of course, we're supposed to divide that by a, which in this case is 1, which doesn't do anything. So there's the sum of our roots. Apparently, our answers will add to negative 15. Now for the product of our roots. Well, it's c, which is negative 324, over a, which again in this case is 1. So our product is just this. So apparently the answers to this problem, they add to negative 15 and they multiply to negative 324. And this can be helpful. One instance would be like in a multiple choice test where they give you a bunch of options. And if those options don't do this, add to that and multiply to that, well then they're just not true options. They don't really work, right? So you can check answers really, really quickly to see if they're correct instead of having to plug everything in and see what happens, right? It's a good way to check your work as well. All right, so using that knowledge, we're going to reverse engineer. So 10-4 says this. It says we know the sum of our quadratic. right? The roots of our quadratic will be negative 3. And we know the roots will multiply to negative 40, right? The product of those roots will be negative 40. So they say find the original quadratic and then find the roots, right? Find when it equals 0. So if I know my sum is negative 3, and I know the sum always is negative b over a, and I know my product is negative 40, and that's always c over a, and I'm looking for a quadratic, right? That's going to look something like this. Well, looks to me like we could make a 1 and b could be 3. And that'll get us negative 3. And we could make a1 and c be negative 40. And that would get us negative 40 here. So apparently, our quadratic is a is 1. Cool. B is going to be 3, so that when we plug it in, we get negative 3. So b is a positive 3, right? We want the opposite of whatever the b value is to be negative 3. So our b value must be 3. And then c is going to be minus 40, because whatever c is what we want here. So there's our quadratic. I don't know. Makes sense to me. And then it says solve and find the roots. So we need roots that'll add to negative 3, and they'll multiply to negative 40. So adding to negative 3 and multiply to negative 40. If we factor, we'll know we need a plus and a minus so that they multiply to a negative 40. And I'll show this one. Here are all the options for multiplying to 40 with whole numbers. So 1 and 40. Oh, I said I'd show it. There we go. So 1 and 40 is a way to multiply to 40. 2 and 20. 3 doesn't go into 40 because I know it goes into 30, 33, 36, and 39. 4 does, though. 4 and 10. 5 does. Be 5 and 8. 6 doesn't, because if 3 doesn't, how could 6? 7 doesn't, because it goes into 49 and 42. And of course, 8 does. So which of these are going to not only multiply to negative 40, but I'm going to get this many x's and that many x's to get positive 3x's? Well, it's 5 and 8. I want a positive 8 and a negative 5 so that I end up with this and this. 8x's minus 5x's will get us that 3x's. So there's our correct factorization. And of course, our answers are negative 8 or 5. Either of these will work in our original problem. So this looks like a really tough problem, but if you understand that the sum of the roots will always be this, and the product is always that, you can reverse engineer to figure out what a, b, and c are. And notice these our roots, they do add to negative 3 and they multiply to negative 40, as predicted. So that was 10-4. Here is 10-5. It's a spicy problem with a star. And a lot of people get confused by this. The question they want to know is, what values of r makes this whole thing equal 0? Well, first off, not everything is on the left side equaling 0. That's kind of weird. So a lot of people are going to want to change that right away, and I think we should. So I'm going to use a property of equality, and I'm going to subtract this entire term, because it's multiplying. It's all one term, technically. Right? Remember, parentheses mean treat it like one idea. So I'm going to subtract that entire thing. That becomes 0. And of course, I have to subtract the same thing from this side. I'm not going to write it twice because I'm saving ink. So what I end up with is r squared plus 5r minus 24 times r squared minus 3r plus 2. And then we're minusing all that stuff, right? So minus 4r minus 10 times the quantity of r squared plus 5r minus 24, and that'll equal 0. And that's the question we want to answer. When will this equal 0? Cool. So the problem right now is that if I were to get one of these to equal 0, yeah, that would make this 0 too because they're timesing. But because this is a minus sign, it's a separate term, right? We have two separate terms here and here. If this is 0 and this isn't, well, then we're not going to get 0, right? 0 minus something who's not 0 will not get you 0. So I need to get rid of that minus sign somehow. So what we're going to do is we're going to factor. as much as possible. I need to point out something. A common mistake people made is they noticed that these are the same. And that's totally great. That's awesome. But then they said, what if I divide this term, and the 0 by this? Then these go away and the problem becomes easy. And that's true. It does become easy. And it's not an illegal move. But the problem is when you do that, you're actually eliminating some of your answers. Because when you divide out those, notice this, if it distributes, will become a quartic equation, right? R to the 4th. But if that's gone, it won't. And so you only get 2 answers instead of the 4 that you expect. So don't divide to do that. You'll lose some of your answers. Instead, what we're going to do is we're going to just factor these as much as possible so we don't lose anything. And what's nice about those being the same is that here and here you'll get the exact same thing. So you don't have to think very hard. Once you get one, you get the other. So here we need R and R. We need a plus and a minus to get negative 24. And we need numbers that'll have a difference between them, because one will be positive, one will be negative. Difference between them of 5. So what numbers multiply to 24 and are separated by 5? Well, it's 8 and 3. And I want a positive 8 and a minus 3. So I get positive 5 out of that. Now, as I said before, this is the same thing. So we get this and this. Over here, I need R and R. And I need a double negative so that I multiply to a positive and I add to a negative. Only way to multiply to 2 is 2 and 1, so I hope it works. And it does, right? Negative 2 and negative 1 make negative 3. So now that we're here, we've got everything factored. And you should notice that between this term and that term, we've got an R plus 8 in both. Duh, right? We've got an R minus 3 in both. Duh. Right, because I originally had both of those. And then this I left, because a lot of people would leave this alone and not factor, but if you think about it, right, what common factor do 4R and minus 10 have in common? Well, they both have a 2, right? So we could take out a 2 and get 2R minus 5, but again, it's up to you, whatever you want to do. But I'm going to factor these out. So I'm going to write R plus 8 and the R minus 3 that I'm taking out of both. And then what's left over is R minus 2 times the quantity of R minus 1. And if you were to check, both of those times this gets us back to this term. And then we have minus 4R minus 10. And if you were to check, both of those distributed to this, we get back to here. So it's the exact same problem. And we still have this minus sign, which is kind of annoying, right? But we can get rid of that really quickly, and here's how. So I'm just going to write these in regular color now that you see where they're coming from. And what's left over here, I'm actually going to distribute so I can get stuff and combine my r's and constants. So r times r gets us r squared. R times minus 1 gets us negative r. That gets us negative 2r's, and that gets us plus 2. Then if we minus the 4r and we minus the negative 10, we end up here. I'm going to combine like terms. And what we get now is r squared. I'm going to combine these to negative 3r's plus this one. So negative 3r's minus 4r's is negative 7r's. And of course, this and this combine to plus 12. And while you might think, wait a minute, we went from having 2 terms here, now we have 3 terms. That's awful. But what can we do with this? Well, we can factor that into 2 binomials. So I know I need r, and I need double negative to make a positive 12 when I multiply, and a negative 7 when I add. What numbers multiply to 12 and add to 7? Well, we got 12 and 1, 6 and 2. Those don't work, but 3 and 4 are the ones we want, right? They'll multiply to a positive 12 and add to a negative 7. So now we've got our answers. If any of these become 0 because they're all timesing, the whole thing will be 0. So negative 8, 3 with a multiplicity of 2, and 4. There are 4 answers. So I'm going to back up and go it over again real quick. We had this problem. we rearranged to make it equal 0, right? That's kind of how we do things. Because there's a minus sign, we want to factor as much as possible. And when we did, we noticed we could factor from these two terms, this term and that term. We took all that out. From here, we tried to combine like terms so that we could factor this quadratic. And now that it's all timesing, the answer is easy. So that's it for section 2. Another video will be uploaded soon.